Hey YouTube, it's Booth Dog here with an actual dog. Say hi to Simba. He was my childhood dog growing up and he just fell. He's getting a little old. Anyway, I thought you might want to see him. We'll turn it over to Mr. Boothman here to get started on today's lesson. Keep reaching out. Join the Google Meet later if you need to. See you soon. Good morning, happy Thursday. We're almost at the weekend here, although personally every day feels kind of like a weekend. It's very strange. Announcements to start our day. You do have an exit ticket that will be due by midnight tonight. This is just again asking you to submit any questions you have from today's lesson. Okay, today's video should be pretty short. At this point, we're really just practicing our skills in 8.3. Just to recap a bit, and this is in your mastery sheet. When we're solving, okay, if our region goes all the way up to whatever our axis of revolution is, then a cross-section is a solid circle. So we only have one radius. It's pi r squared. That's what we're integrating, okay? If there's any kind of a gap, so let's say we have this region and we're rotating around this line. There's this big gap in between here. That means that we're creating a washer. So this is where we have two radii. Okay, so where we're using our v equals the integral from a to b of pi and then big R squared minus little r squared. Big R, okay, that's dependent on the function that's furthest away from our axis. Little r is the function that's closest. And for either of those radii, remember that a formula that works every single time is function minus the axis of revolution, okay? Remember, sometimes we integrate this with respect to x. That's if we are revolving about a horizontal line. If we revolve about a vertical line, then we're integrating this with respect to y. So we just need everything in terms of y, okay? Yesterday, I asked you to work on page 4 of your mastery sheet. Today, we're looking at page 5. Okay. Now, the setup is pretty straightforward. Notice first, let me clarify, this is a no calculator question. The square root of 6x plus 4, so that is going to be, hopefully we at least recognize the shape. Okay, so square root of x would be this shape. That plus 4 is shifting it to the left a little. That 6 is going to be a stretch or compression. In general, just something vaguely like this. Okay. The line y equals 2x. Okay, so that's just a diagonal line, but it's a little steeper. And the y-axis. So we're looking at this area right here. So I'm going to redraw this, focusing on just that area. Here we are. Find the area of this region, first of all. So I think you can set that up yourself. This answer key is already posted, so go ahead and check your work as you go. But area, of course, is the integral of top function minus bottom function. Okay. We do actually need this point of intersection. Okay, so we know our limits of integration. Again, we find that by setting our two functions equal to each other, solving for our x values. So hopefully you get 2. So take care of part A. You should get an answer of 20/9. Part B, set up but do not integrate. So here's where I say this is actually a lot of AP questions that assess this concept. Ask you to set up but not actually integrate these integrals. An expression in terms of a single variable for the volume of the solid generated when R is revolved about the x-axis. So we're revolving this entire region this way. It's coming up out of the board, hits the board, goes into the board, and then back around. All right. What is the shape of a cross-section? Is that a solid circle? Of course not. It is a washer. Okay. So we would set up our integral v equals the integral from 0 to 2 of pi and then big R squared minus little r squared. And this is with respect to x. Okay, so again, check your answer there. But the only problem I actually really want to go through today with you is part C here. Part C is a very similar question, but now it's asking us to revolve this region about the y-axis. So we're revolving this way, up out of the board, into the board, back around. We end up with this shape. Now we're revolving around a vertical line, so instead of integrating with respect to x, we should integrate with respect to y. So we're looking at cross sections this way, but this shape itself is a little different. Okay? If you notice, right here, what's the shape of our cross section? A solid circle. But what if I take a cross section up here? Is that a solid circle there? Or do we have this gap? Turns out that part of this shape has circular cross sections, okay? And the top part of the shape is a washer. So how are we going to integrate this? Okay. It does get a little tricky, which is why I wanted to do this one together. So from 0 to, we need to figure out this value here. Again, we're integrating with respect to y, so we're using y values. Okay. Our shape is a solid circle. Shape of a cross section is solid circle. The top part of this shape, okay, has cross sections that are washers. So we're going to split this up into two separate integrals to find our volume. For this bottom part, okay, we have the integral from, again, these are y values, we're integrating with respect to y. So this is the integral from 0 to, now we need to find this value here. Okay, we're solving this for when x equals 0. So if we plug in 0 for x, solve for y, we get y equals 2. So this is the integral from 0 to 2 of pi. And this part is just a circle. So what is the radius of this? It's just this function, which was y equals 2x. But we're changing it with respect to y. So we're plugging in y over 2 dy. So that's this first piece. And then to find the top part of this, we are adding. We have the integral from, now here we're starting at 2. We are going up to, what is this y value? Well, we know the x value there is 2. If we plug in 2 to this function for x, we get the y value, the square root of 16, which is 4. And this top half of this shape has cross sections that are shaped like washers. So here we have pi times, we need big R squared minus little r squared. Big R is the furthest function from our axis of revolution, which is still y over 2, minus, now we need the function that's closest to our axis of revolution, all in terms of y, so we need to solve this for y. If we do that, we get x equals y squared minus 4 all over 6. So that is little r. Again, dy. This is our final answer for the volume of this shape. Okay, so parts A and B, pretty straightforward. Okay, things that we've been practicing, hopefully you're getting more comfortable with. This right here, I totally understand it was trickier, but it's the same concepts, it's the same rules that we've been practicing. It's just recognizing that part of the shape had circular cross sections, part of the shape had washer cross sections, all right? It's really all the practice I wanted to go through today. So at this point, I will ask you to complete the 4th and 5th pages of your 8.3 mastery sheet. We will spend tomorrow looking at the rest of this mastery sheet, pages 6 and 7. We're going to skip page 8. You do have that exit ticket due at midnight tonight. Otherwise, join our Google Meet if you have any questions, and I'll see you tomorrow. Fantastic lesson as always, Mr. Boothman. Thank you so much. I'll see you all tomorrow. Make sure to hit that like and subscribe button on your way out.